We'll practice finding electric field, force, and acceleration for an electron between parallel plates. Here's the problem. Two parallel plates are separated by 0.020 meters with a potential difference of 500 volts. Given the electron charge and mass, find the electric field strength between the plates, the force on the electron placed in the field, and the electron's acceleration. First, recall that for a uniform field between parallel plates, the electric field strength equals the potential difference divided by the separation. So E equals V over D, which is 500 divided by 0.020, giving 2.5 times 10 to the 4 volts per meter. Next, the force on a charge in an electric field is given by F equals Q times E. Plugging in the electron charge and the field strength, we get 1.6 times 10 to the minus 19 times 2.5 times 10 to the 4, which equals 4.0 times 10 to the minus 15 newtons. Finally, use Newton's second law to find the acceleration. Acceleration equals force divided by mass. So A equals 4.0 times 10 to the minus 15 divided by 9.11 times 10 to the minus 31, which gives 4.4 times 10 to the 15 meters per second squared. Remember, for parallel plates, the electric field is uniform and equals V over D, then force is QE, and acceleration is F over m.